Rolling. Okay, this is the Stirling engine, and I just measured out 10 milliliters of ethanol that I'm going to pour in here, and that one is going to be quite full. Okay, -1, so it's going to be 9 milliliters of ethanol. It's not exactly 9 grams, it's probably in the neighborhood of 8 grams because the density of ethanol, of course, is not 1, unlike that for water. As I put this cap on here, probably some ethanol will seep out. In fact, it does. Could you? Oh, there it is. Because I don't necessarily want to get the fire on the table, even though these lab tables are made for withstanding fire. And then the rest ethanol that I have left here, I may want to remove that before I start the flame. Okay. Because once I start a fire here on the side, then more and more ethanol will seep out, and it's going to make it not look good. So there we go. That'll take a moment. Okay, let's see. For the Stirling engine, I guess at some point I was able to take this apart. Either that, or I just determined that these are aluminum, these discs, and figured out what the dimensions are, and that's how I came up with the 36 grams for each of these, so for a total of 72 grams, or 0.072 kilograms. The radius, if you look at it, well, looks almost like an inch here. That's why I wrote down 28 millimeters. It's a disc, as you can see. So again, you have to look up in the book. You come up with the 1/2 mr squared for the moment of inertia, and then of course we're going to measure the frequency once it gets going and the stoppage time. And this time we're going to measure the total time. Respectively, a total time is probably going to be in the neighborhood of 10 minutes, so I'll write that down in the caption of for this video. Yeah, I'm just going to let it heat up here. It basically just works by air. I put the ethanol as my fuel here, but that's heats up the air that's inside the cylinders, and then it's the expanding air that will push out the piston. So it's still a heat engine, it's just not a steam engine. There we go. In fact, at this point, I'm going to start the clock, and it says pretty much 9:15 here. We're probably going to be in a neighborhood of 10 minutes or so. We'll see. And again, I put a little white mark on here. I believe I did. Oh, it's a little black mark. Where I can use the strobe light, so if somebody can turn off the light. I don't actually know if that with the strobe light, if that shows up on the camera. So yeah, that's pretty stable right there. You could turn the light back on, and then I can read. I come up with 1,300 rounds per minute, which means again divide by 60 in order to get it the frequency in hertz. Okay, the other thing that I need is the stoppage time, and I'm going to blow out the flame and we're going to count a second how long it takes to stop. And here we go, 1, 2, 3. How much was that? 10. Okay, about 10 seconds. Lighting it. So stoppage time is 10 seconds, and then except for the total time, I pretty much have determined everything, and we can do the calculations on this one. Okay, thanks, because the rest would be now